Imagine this. It is 2 a.m. in the morning and the company's system has been compromised. An attacker has successfully stolen sensitive data, moved across the network, and also created a backdoor for future access. But here is the scariest part. The evidence has been there the entire time. Every login, every fake password, every suspicious network connection, every command executed, it was all recorded. The problem wasn't lack of evidence. The problem was the evidence was scattered across hundreds of different devices, producing millions of logs every single day. Finding this kind of evidence would be like looking for one single sentence in an entire library. So, how do security teams make sense of all that data? How do they connect a failed login on one server with a firewall alert and an unusual PowerShell command on another machine? The answer to this is a technology that has become the backbone of modern security operations center. It is called a SIEM, Security Information Event Management. By the end of this video, you're going to know what a SIEM is and why organizations can't defend modern networks without it. I am Eboh FN and this is Cyber Knowledge Bank on Secneedle. I'm going to tell you what a SIEM is, but I figured in order to make it stick, it is best I paint you a picture of how it works first. In this image from TryHackMe, we see what a network looks like. Of course, you know that a network is a group of devices connected together to talk to each other and share data. Here we see how computers, servers, and the internet are connected together in an organization like a school, office, company, and so on. But the focus of this video is not to teach you networking. We are going to do that in subsequent videos. The aim here is to show you why SIEM is needed in a network setup like this one. For the sake of emphasis, I'm going to discuss why we need SIEM on 4 levels. The first is detecting lateral movement. Now imagine an attacker tries to log into the data server. Without a SIEM, that failed login is recorded only on the data server and the administrator may never notice it. But when there is a SIEM on that network, it collects that failed login, and when there are many failed logins, it generates an alert. Let me take you back to the picture I showed you earlier. In a network setup like this, you have multiple moving parts. Operating systems like the Windows and the Linux, different infrastructures like the web server, the data server, and an open doorway to the outside world, which is the internet. And that is happening through the router. If it is the case of a hacker compromising one of the 50 Windows workstations, the first thing he's going to do is what we call the lateral movement. That is, hopping across the network to look for targets of high value. He could use the network connections via the router to access the Linux server or the data server. This is where it gets very interesting. Individual computers only see their own logs. A Windows machine might not know that it has sent a bad request to the Linux server, and the Linux server might just see a single failed login. In this situation, we need the SIEM to connect in real time these dots to understand what is happening on the network. The second level showing the need for a SIEM on a network would be the protection of high-value targets like the servers. You see, I would like to call the web server and the data server the crown jewel of a network. Do you know why? Web servers face the internet, and it is because of that they are constantly bombarded with automated scans, SQL injection attempts, DDoS attack coming through the router, and so on. Data server, on the other hand, contains companies' sensitive data. Any unauthorized access or massive file download, which could of course be a potential data exfiltration, need to be caught instantly. Here, the SIEM correlates the traffic hitting the router and the activities on the web server and the data server. If it notices any spike in internet traffic that is followed immediately by a database export on the data server, it creates a critical alert. The third level at which you need a SIEM on a network would be bridging the gap between operating systems. You see, operating systems like Linux and Windows speak entirely different language when it has to do with logging of events. Linux workstations and data servers generate text-based logs like syslog and autlog. This tracks root access, SSH connections, and file permissions. Windows workstations, on the other hand, generate binary event logs like the application logs, security log, systems logs. All these help track Active Directory logins, PowerShell execution, and registry changes. Here, the SIEM works as a universal translator. It collects the different logs formats from all the different workstations, irrespective of their operating systems, normalize them into a single format, and allow the security personnel analyze them from one dashboard. In summary, the job of a SIEM on a network is to take the log from the router, the web server, the data server, the Linux workstation, the Windows workstation, combine all of them into a single cohesive timeline. It transforms a blind spot into absolute visibility, allowing you to catch threats before they cross from one side of your network to another. If at this point you are asked to give a simple explanation of a SIEM, you could simply say that it is a centralized security system that acts as the brain of an IT network defense. You could go ahead to say that it is a cybersecurity solution that collects, analyzes, stores, and correlates security logs from multiple devices on a network. This helps security team detect, investigate, and respond to security incidents. Instead of the administrator checking each device separately, the SIEM provides one dashboard that monitors the entire network for suspicious activities. Some of the popular SIEMs we have out there are the Splunk, the IBM QRadar, the Elastic Security, the Microsoft Sentinel, and so on. Let me walk you through some of the things you are going to encounter if you choose Splunk as your choice SIEM to work with. Okay, let's take a look at what a SIEM looks like. We are particularly working with Splunk. Splunk is, like I said earlier, is one of the SIEMs that we have out there. What you are looking currently on the screen is your more like your home page, right? Where you have the tools that you are going to be working with. So the purpose of this video is to help you understand the things that you are going to see on your own environment when you log on to your Splunk environment. When you first log into Splunk Cloud, right, you are greeted with this home dashboard. Now, think of this as a control center where administrators, security analysts assess the different capabilities of the platform. Starting on the left, you're going to notice the app panel. As you can see here, Splunk is organized into applications where each app is actually designed for a specific purpose. Now let us start with the most important one here, which is the search and reporting. I think this is one of the most important tools for the security analyst, because this happens to be where you spend most of the time searching through logs. This is where you investigate incidents, you even build dashboards, right? Now below there are several other apps. For instance, we can see here the audit trails. This keeps track of administrative actions. It shows who had made changes to the system. Below it, you can see the cloud monitoring console. This actually provides health and performance metrics. We can also see below it the data management. This is used to configure and organize incoming data sources. You will also notice Universal Forwarder. It is an important component because it is responsible for collecting logs from servers, workstations, and other devices. Then, it securely forwards this log into Splunk for analysis. At the top of the page, you will find the navigation bar. Here you can search across platforms, you can access notifications, you can manage settings, you can even switch between different Splunk applications. This is actually your main navigation area. Right now you're looking at the home page, which provides shortcuts to common administrative tasks. Let us take an example of the first one on the left, which is the add data. This add data function allows you to connect new log sources such as Windows event logs, Linux servers, firewalls, cloud services. Now, since a SIEM relies entirely on data, it is usually one of the first steps in setting up your platform. The next we are going to look at there is the search your data option. This takes you directly into Splunk's search interface. This is where analysts will investigate events and hunt for suspicious activities. The next we are going to look at there is the visualize your data. This lets you create dashboard and chart. You'll be able to transform raw log data into graphs, metrics. It makes it much easier for you to identify trends and anomalies on the system. Just close to that, you are looking at the manage alert function. This is where analysts configure notifications. This actually means that they configure notification in such a way that once a predefined security conditions are met, the notifications are triggered. This helps because instead of reviewing thousands of logs, Splunk can automatically notify analysts when something suspicious occurs. Now let us look at the tiles below. These remaining tiles provide administrative features like documentation, community resources, training materials, and so on. You see, why they are actually useful, they may not really be part of the day-to-day workflow of a security operations center or a security analyst. Before we look at something else, I would like to add here that this homepage is not where the investigations actually happen. Just think of this as a launch pad. Once logs are being collected, analysts typically move into the search and reporting application where they will search through the events, correlate the activities across different systems, and also investigate potential security incidents. And that is where we are going to next. Now we've entered the search and reporting application. This is where the real work happens. You see, every login attempt, every firewall event, every VPN connection, every Windows log, every security alert eventually ends up here. This interface is where security analysts search through thousands of events to answer just one simple question. Is something suspicious here? Or is something suspicious actually happening on the network? Now let's break down this interface. I am using this image from Splunk because through the numberings of the parts of the search and reporting section, they've simplified and made it much easier to understand what is involved here. Now let us look at the area tagged 1. That is the navigation tab, and there you can see the different workspaces within the search and reporting app. Now the search tab is where analysts investigate raw log data. Other tabs provide tools for analytics, dataset, report, alerts, dashboards, and even reusable modules. Even though these features serve different purposes, almost every investigation starts in the search tab. Now let's look at the area tagged 2. Here you will notice that Splunk uses something called SPL, Search Processing Language. Instead of manually scrolling through logs, you can write searches such as show me every login during the last hour, find every connection made to this suspicious IP address, and all of that. Just close to that, we have the SPL2 option. SPL2 is a newer version of Splunk search language, that is designed to be more consistent and even easier to read. However, many organizations still use the original SPL, but you are going to encounter both versions depending on the environment you are using. The next thing is the search bar. I think it is safe to say that this is probably one of the most important part of this entire interface. Everything actually begins here. The analyst will type search queries to filter through enormous amount of log data. For instance, you can see that the search that is currently being performed is looking for the main index, which is one of the locations where Splunk stores collected events. You see, as searches becomes more advanced, analysts can filter by username, IP addresses, event IDs, timestamps, host names, specific attack indicators, and all of that. Now let's look at the item tagged 5. That is the time range, right next to the time selector. One thing to note here is that security investigations always happen within a specific time frame. Maybe you are investigating an activity from the last hour, or an activity from the last 24 hours, or an exact moment an alert was generated. This time filter allows analysts to narrow their search without scanning through unnecessary data. The next item we have in this interface is the search button. Once you've written your query and selected the time range, what you just simply do is to just click the search button, and Splunk will immediately start searching across all the indexed events that match your criteria. Now the item we have close to the search button. The search button we can see there is tag 6, and the item just close to that will be what we'll call the search assistant. Now, search assistant, just like the name implies, it helps provide suggestions, syntax help, guidance. As you write your SPL queries, it provides some suggestions, it gives you syntax help, it also gives you some sort of guidance, making it easier to build complex searches without you trying to memorize all the commands. The item tagged 8 is called the search mode. This particular function in Splunk offers different search mode that tries to balance speed and detail. For instance, smart mode automatically help you decide how much information to return, while helping searches complete faster and still provide you with the very useful information or result that you need. Now the item tagged 9 here is the search history. Every search you have previously executed is stored here. This is very useful during an investigation because analysts will often revisit earlier searches so that they can build previous queries instead of starting afresh. Now the item tagged 10 on the left is called the learning resources. These are documentations and tutorials that help users learn the platform and understand how to search effectively. They are particularly useful if you are just getting started with Splunk. And the last item we have here is the item tagged 11, the SPL2 learning panel. This function provides documentation and guided examples for writing more advanced searches. But in reality, as analysts become more experienced, they rely less on these resources. Rather, they pay more attention and spend more time writing custom search queries. At first glance, this interface may look very simple because we are just seeing the search bar and few buttons, but don't let that fool you because this single search bar gives analysts the ability to search across logs from thousands of devices, correlate events from completely different systems, detect malicious activities, reconstruct an attack from the start to the finish. I mean, in many ways, this is the heart of Splunk. Everything we've discussed about SIEM, collecting logs, storing data, searching events, and investigating incidents all come together right here. Okay, at this point, I think it is necessary I show you what this interface looks like after you've executed a search. You can see that the interface has changed a little bit. Now, instead of showing an empty search page, Splunk is now displaying thousands of matching events. This is where analysts begin examining evidence, piecing together what had happened during a security incident, and all of that. Let me walk you through some of the different sections here. Now, the first function tagged 1 is the save as. Once you've written a useful query, you can save it for later, create report, build dashboard, and share it with other analysts. In a security operations center, analysts often save searches that are used repeatedly for threat hunting and incident response. And the function tagged 2 is the job controls. Whenever you run a search, Splunk creates what is called a search job. This control actually helps you pause the search, stop it, refresh the results, inspect how the search was executed, or even download the results for future analysis. This can become very useful when you are searching across thousands or millions of log entries, where a search may take some time to complete. Now let's look at the item tagged 3. This is the results view. Once a search finishes, Splunk lets you view the result in different ways. The event view, which displays raw log entries, especially as they were collected. We also have the pattern view that automatically groups together similar events. This makes it easy to spot unusual behaviors. While the visualization tab, on the other hand, can generate graphs and charts from the same search results. The flexibility that this gives allows analysts to examine the same data from multiple perspectives without running another search. Now, the item tagged 4 is the event timeline. You see, each green bar represents the number of events collected during a specific period. This visualization helps analysts to quickly identify spike in activity. For instance, if thousands of failed login suddenly occur within a few minutes, the timeline immediately highlights that unusual burst of activity. Instead of reading every log one by one, analysts can jump directly to the time period where something suspicious happened. On the left is one of Splunk's most powerful features, the field panel, which is tagged 5. Every log contains pieces of information called fields. These include things like source IP address, destination IP address, username, host name, event type, the HTTP status code, and many others. What Splunk does is that it automatically extracts these fields so that they become searchable. To throw more light on that, rather than manually reading every log entry, analysts can simply click on a field to filter the results, group similar events together, or investigate specific users. It could also investigate specific devices or even specific IP addresses. This actually can speed up the pace of investigations. And lastly, we are going to look at the item tagged 6, which is a search result. At the end of the day, we have the actual event that has returned from the search. If you pay very close attention, you're going to see that each row represents a single log entry collected from one organization's system. If you pay very close attention, you're going to notice that every row represents a single log entry collected from one of the organization's systems. In this particular example, we are looking at a web server log. If you look closely, you're going to notice that each event contains a timestamp showing exactly when the activity occurred, followed by details such as the client's IP address, the HTTP request that was made, and also the server's response code. To add to that, you can see the metadata like the source of the log and its source type. These entries may look a bit difficult to read at first, but they are the raw evidence that an analyst will use to reconstruct the attack. Through searching, filtering, and correlating these events with logs from firewalls, authentication servers, endpoint security tools, and other systems, an analyst can build a complete picture of what has happened during an incident. In my opinion, this is where the true power of a SIEM becomes clear. Instead of logging into dozens of different devices to collect information, all the relevant events are centralized in one platform. This actually means that from a single search interface, an analyst can investigate activities across the entire organization, correlate this event from different systems, and also uncover attacks that would have been nearly impossible to detect by examining each log source individually. I think this is why the search interface is often called the heart of modern security operations center. Now, what we have in front of us is one of the great tools that you are going to find in Splunk. It is called the pattern detection. You see, many persons assume that analysts manually inspect every log, but this pattern tab shows how Splunk automatically groups similar events, making investigations much more efficient. So we've been looking at individual log events, but if your search returns not hundreds, but hundreds of thousands of events, what do? Reading every single log entry will be nearly impossible. This is where the pattern feature becomes very useful. Instead of displaying every event one by one, Splunk automatically analyzes the search results and groups together every event that share a similar structure. Now look closely at the top, you're going to see that this search returned over 112,000 events. Rather than expecting a cybersecurity analyst to examine every one of them, Splunk has identified 14 unique patterns based on a sample of those events. Each pattern represents a type of event that appears repeatedly throughout the dataset. You will also notice the smaller and larger slider. This controls how broadly Splunk groups similar events. Moving the slider towards smaller creates more specific patterns, separating events based on small differences. But if you move the slider towards larger, it combines similar events into broader categories, and this makes it easier to identify the most common types of activities. This tells us what portion of the search result matches that particular pattern. For instance, the first pattern represents about 11% of all matching events. The next pattern accounts for roughly 9% and so on. This percentage helped analysts immediately understand which type of event are occurring most frequently. Now let's look at the patterns themselves. We can already begin identifying different types of activity. Some entries shows HTTP requests from the web server, others contain successful user authentications. We can also see the user logout and also the email server messages related to mail delivery. Importantly, this function becomes very valuable during threat hunting. Imagine searching through millions of logs after a security incident. Instead of manually reading every event, you can quickly identify common patterns and then focus your attention on the unusual ones. In summary, we can say that the pattern view helps analysts separate routine activities from potentially suspicious behavior, and this will allow them investigate anomalies much more efficiently. I think this lays more strength to what we've been saying all along in this video, that a SIEM doesn't just collect logs, it helps the analyst make sense of enormous amount of data. And this brings us to the end of today's video. I hope you've learned what a SIEM is, how it works behind the scene, and why it is such a critical tool for modern security operations center. Whether you're just getting started in cybersecurity or you're looking to strengthen your security knowledge, understanding how SIEM works will be a tool that will help you throughout your cybersecurity career. If you would like to dive deeper into cybersecurity topics, head over to Secneedle.com to read the latest article titled "Why AI is Forcing Organizations to Rethink Cybersecurity." It promises to be a great read. And also, be sure to follow us at Secneedle on all social media platforms to get the latest cybersecurity news and tips. Thank you for watching, and I will see you in the next video with another cybersecurity related content. Until then, stay safe and stay secure. I will see you in the next one.